Hello, everyone. My name is Samantha Bruton-Hunter, and I work in the Policy Office at the National Science Foundation. It is my pleasure to welcome you today to the Fall 2023 NSF Virtual Grants Conference. I'm now pleased to present this session, which will cover the programs in the Mathematical and Physical Sciences Directorate. This session will be presented by Matthew Douglas.
So welcome to the overview of the Directorate for Mathematical and Physical Sciences. My name is Matt Douglas. I'm a program director in the Division of Mathematical Sciences in the Directorate for Mathematical and Physical Sciences. And this slideshow is going to talk about Introduction to MPS, which is the acronym for Mathematical and Physical Sciences. All right, so here's a quick overview of the talk. So we'll start with a general overview of the Directorate. So this will include the organizational structure, roles, and missions of the 5 divisions in MPS, some information about budget, funding. That's the first section. Then there'll be a sort of a smorgasbord of multidisciplinary, cross-directorate, and interagency research and instrumentation programs in MPS. So this will include, the last slide will actually be about the career program, the NSF-wide career program. After that will be an overview of some MPS broadening participation programs. These are relatively new, most of them. And finally, a little bit about undergraduate research opportunities, both for students and for faculty. Okay, there's a lot of ground to cover. Some of it you might have seen in other sessions. There's an hour for this. Actually, I think there's only 40 or 45 minutes for this presentation. So some of this stuff will go by pretty quickly, so there's time for questions. And my assumption is that you have the slides available to look at on your own time. Okay, so let's go. So here's a picture of the NSF organization chart, just sort of FYI. At the top, sort of on the left, is the National Science Board, which in some sense is the National Science Foundation. And then under that is the Office of the Director. Underneath the Office of the Director, going down in this picture, are all the directorates. There's 10 directorates. 2 of them are sort of business oriented and 8 of them are scientific directorates. So there's TIP, which is Technology, Innovation, and Partnerships, Biological Sciences, Computer Science, which is SCIES, Engineering, Geosciences, Mathematical and Physical Sciences, MPS, that's highlighted, Social, Behavioral, and Economic Sciences, SBE, and STEM education, that's ED, it used to be EHR, but it's been recently renamed. Now it's the EDU Directorate. Okay, so that's the overview of how everything sits inside of NSF. We're going to be looking at MPS. Okay, so the mission of MPS is to harness the collective efforts of the mathematical and physical sciences communities to address the most compelling scientific questions, educate the future advanced workforce, and promote discoveries to meet the needs of the nation. If you've seen the NSF mission statement, this is pretty close, and most of the mission statements sort of copy that. This is not really any different than the others, okay? And the division supports all kinds of disciplinary and interdisciplinary activities, and as I already said, the second part of this presentation is, the goal of it is to highlight some MPS multi and interdisciplinary activities that are MPS with other directorates, MPS with other directorates with other agencies, MPS with other agencies, and different things of that sort, along with different kinds of funding opportunities. That there's a lot of variation. The idea is to give you a sense of the breadth of the opportunities in MPS. So before that, we're going to start a little bit with the nuts and bolts of how MPS is organized. So as you can see, MPS houses a diverse set of divisions, not assembled around a single unifying scientific discipline, which is sort of an opposite, as opposed to biology, which is biology, engineering, which is engineering, and so on. MPS has 5 divisions. They're astronomy, astronomical sciences, chemistry, materials research, mathematical sciences, and physics. And then there are several sort of assistant director level offices. So the assistant director is in charge of the directorate, and the assistant director sits underneath the director of NSF. Okay, now in each of these little bubbles for the divisions, you can see the different sorts of opportunities each division offers. So for example, Astronomical Sciences, they have individual investigator programs, mid-scale instrumentation. So that's telescopes, major facilities, that's bigger telescopes, I assume. And then they have REUs. And it kind of goes the same across all 5 divisions. At the beginning, our disciplinary programs or individual investigator programs. These are all the programs that cover individual investigators. The slides that are kind of coming up are going to cover these next group of bubbles underneath each, give you examples of these sort of what occurs in these bubbles under each division. MPS has a brochure. I'm not going to belabor this. You can download it and read all about it. It was last updated in, well, it's from 2020. The publication date was 2021. If you want more up-to-date information certainly about the financial aspects of MPS, you can get that from the NSF request to budget request to Congress for FY24. That has a lot of details in it. That's available from the NSF website. All right. So before we get into a little bit more numbers about what NSF funding numbers, this slide has an overview of NSF support of basic research in selected fields. So this is, I mean, if we look at the 37% for physical sciences, roughly speaking, NSF funds 30% of the basic research in physical sciences in the country. NSF supports 71% of the basic research in mathematics and 79% in computer science. So you can see that how much individual investigators rely on NSF depends a lot on their discipline. All right, so here's MPS by the numbers. And I should warn you, if you compare this slide with the next few, you're not going to get exactly the same answer out of each slide, because the counting these things it really gives you a good ballpark estimate, I think, is the way to think about numbers when it comes to data for large programs or large units like MPS and NSF. But roughly speaking, in FY21, there was 1.6 billion in awards that went to almost 2,500 competitive awards. Competitive means that they got reviewed and a recommendation was made to award or decline. There were about 8,000 proposals were submitted to MPS, and of these 2,500, roughly speaking, 2,500 awards, they touch about 30,000 people. And then the column on the right shows you how they're touched by sort of categories of researchers or individuals. And one thing to notice is that the senior researchers, that's almost the biggest. It's basically tied with the number of graduate students if you sort of count them person by person. And the others are somewhat smaller. All right. This slide tells you about the funding rates. These are NSF funding rates, and they're funding rates over time from 2017 to 2021. And you can see it's been creeping up slightly. The yellow is the funding, the number of awards. Blue is the number of proposals. So in 2017, there were almost 50,000 proposals, 11,000 awards. The awards are 11,500. The number of awards has stayed roughly speaking the same, but in FY20 and 21 and 19, the proposal pressure went down. There were fewer proposals, so the success rate went up. Okay, the funding rate went up. That's NSF wide. Here's a different version of the same information just for MPS. So you can see from 2013 to 2022, the light blue at the bottom are the awards. So there are about 2,000 awards. That's relatively consistent. The dark blue is the number of proposals received. You can see there's definitely a dip because of COVID. And then the yellow line, the dotted line, is the percent funded, which of course goes up when the number of awards is constant and the number of proposals go down. All right. Here's another slide that actually gives you, so the last one was funding raised. This is about actual dollars. And the blue line is the actual amount of awards made by MPS starting from 2010 going to 2020. You can see it's roughly constant. It's slightly high. I mean, it was slightly below 1.4 billion in 2010 and slightly above 1.4 billion in 2020. So it really hasn't changed that much. And the, I guess it's silver color. It's hard to say what color that is if you do it by constant 2019 dollars. All right, so that's the numbers. Next, MPS science. So the actual science of the MPS Directorate comes through its 5 divisions. Taken together, these span an astonishing breadth of fundamental lines of inquiry that collectively make MPS a major component of the entire NSF portfolio. And I'll say again, what the goal of the next 10 slides, maybe 15, is to highlight some specific programs in the different divisions that give you a sense of the breadth and interdisciplinarity of proposals and projects that are funded by MPS. This is not it. We're leaving out kind of a big chunk, which is maybe the biggest chunk, but that's also the one that's sort of the most natural, and that's the individual investigator award. So I won't really say much about those. All right. So the first example of one of these large scale multidisciplinary projects is, it's called MFB, Molecular Foundations of Biology. This is joint with MPS in partnership with the Biology Directorate and the Size Directorate and the National Institutes of Health. Okay. And as you can see, the purpose is to pursue creative technological approaches that address questions about RNA function in complex biological systems. So these are really large awards. There have been 7 awards made in this program, $10 million. And part of the reason this is getting emphasized here is that of those 7 awards, they have not all gone to elite institutions on the East Coast and the West Coast. They've gone not even to all R1s. Some of them have gone to R2s, and they've gone to EPSCoR institutions and EPSCoR jurisdictions. So they've really been spread out across the country. Okay, next is, these next few slides are about what used to be called Quantum Leap. It's in parentheses down at the bottom. The current terminology is Quantum Information Science and Engineering. So Quantum Leap, I'm going to call it Quantum Leap because it's hard for me to change my terminology at this point. So this is a cross-directorate mega program in which all directorates participate, and there's also connections with funding agencies outside of NSF for some of these opportunities. And this is just a cover slide to emphasize that the Quantum Leap is about the second quantum revolution. The first quantum revolution being with the people in the picture in the top left, Marie Curie, Hendrik Lorentz, and Albert Einstein in the 20th century, the 1900s. And then the bottom slide is a graphic that is used. It's experimental confirmation of a possible key to future quantum computing. So this is where we are going forward. And the next couple slides are going to give you more information about Quantum Leap, just to give you the idea of the scale. Okay, first are these what's so-called Quantum Leap Challenge Institutes. There's 4 of them. I won't go through each one. You can read the slide. The point is, one's in Berkeley, one's in Boulder, one's in Champaign-Urbana, one's in Chicago, and the last one on the East Coast is in the University of Maryland. So these are big institutes. They're spread out across the country. Okay. On a closer to human scale, is what's called quantum sensing challenges. So this is a smaller opportunity. So which supports interdisciplinary teams of 3 or more investigators to explore highly innovative and original and potentially transformative research on quantum sensing. So this program is, the awards are up to $2.5 million spread over 4 years, and there's at least 3 PIs, probably not more than that, not that many more, but okay. Another program inside of Quantum Leap is in Quantum Information Science and Engineering, so is Expand QISE. So this one is in contrast to the previous 2. This one, the purpose is to broaden participants participation of institutions contributing to QISE. And it's only available to institutes of higher education that in the last 5 years received not more than $5 million from all federal funding sources for QISE research. Okay, an interesting thing about this one is there's 2 tracks. There's an individual track for individual PIs. Those are up to 800,000 for up to 3 years. And then small and medium teams. This is track 2 for 2 to 5 collaborators. And in both of these, somebody at the institution that is submitting the proposal needs to be paired up with a co-PI at another institution. Okay. And you can read the focus areas. And to emphasize where these expand QISE awards go, here's a slide with some details. Track 1 is in blue, track 2 is in gold. And these are 2022 awards. The 2023 awards would sit on top of these, and they would be presumably roughly the same, not necessarily the same distribution, but the same number of awards spread out across the country. Okay, so that's Quantum Leap. That's one of the NSF's 10 big ideas from a few years ago that is sort of its current status that involves a lot of MPS activity. Next, we get a little more specific to chemistry, okay? So chemistry is involved in, kind of the home for some of these sustainable chemistry research activities, of which there are 3 that are highlighted in this slide. These are all Dear Colleague letters. One of them is for micro and nanoplastics. Another is for innovative solutions to climate change. The third is for innovative solutions to sustainable chemistry. And all of these are in collaboration. They're not just chemistry and they're not just MPS. So inside of chemistry, inside of MPS, the other divisions are involved. And then outside of MPS, they're biology, EDU Directorate, engineering, geosciences, and SPE, TIP, they're all involved in one way or another. So these are more cross-directorate programs, sort of focused a little bit on chemistry, actually a lot on chemistry. Okay, an astronomy-based one, or astronomy and physics, is Windows on the Universe. It's a multi-messenger astrophysics. So WOUMMA, this is meant to fund awards that have significant components of multi-messenger astrophysics, and proposals are submitted to disciplinary programs within the relevant divisions, which was the same as with the previous slide. Okay, and mostly these are inside of MPS, it's astronomy and physics, but it's also with GEO because there's a Antarctic installation that's related to this. Okay. The Windows on the Universe. All right. Getting a little closer to home for me, there's computational and data-enabled science and engineering. So this is a cross-directorate meta program, again, involving computer science, engineering, and MPS. And okay, this is what it says. It's about computer science and big data, which involves, in particular, well, mathematics, which is the bullet point at the bottom. DMS, Division of Mathematics, has its own special version of CDS&E, which is called CDS&E-Mathematical Sciences, that I gave you the link for at the bottom. Okay. And I told you CDS&E is a meta program, and it sort of gloms together existing funding opportunities. One interdisciplinary opportunity, sort of a large one that involves Division of Materials Research, is designing materials to revolutionize and engineer our future. So the acronym is DMREF, which somehow seems easy to remember. This is one peculiarity about this one, is it's biennial. So it's only offered every other year. It was just offered this year. That's the solicitation at the bottom, and it will roll around again in 2 years, okay, meaning the year after next. But it has rolled around for a long time. It will continue, as far as we know. And this is a multi-agency. So inside of NSF, it has 4 directorates: computer science, engineering, math, MPS, and TIP. But then it also includes NIST, National Institutes of, I forget what the full acronym is, Department of Energy, and then Air Force, Army, and Navy all have their own individual research offices which participate in DMREF. So finally, the last of these sort of big cross-cutting programs is ADAPT, Advancing Discovery with AI-Powered Tools. So this is, the point is to development or new application of artificial intelligence inspired tools and techniques. So you can see this is, of course, a very hot topic right now. And that's reflected in the types of submissions that are allowed. So that you can only apply to this if you have current funding, in which case you can apply for a supplement, or you can submit an eager. So eager proposals are reviewed internally, and a recommendation is really just made pretty quickly by program directors. Then the award sizes are relatively small. And RAISE, so RAISE is Research Advanced by Interdisciplinary Science and Engineering. This is a mechanism, a funding mechanism for collaborative proposals. Okay, so these examples should give a good sense of the breadth of research supported by MPS and the diversity of types of proposals that can be submitted. In addition, so these are all in addition to the individual investigator programs. So remember that the individual investigator programs are kind of the core of National Science Foundation. Okay, so still keeping on with this theme of sort of large things that are not the core is major research instrumentation. So this is across all directorates. This is what, I mean, if you're a physicist and you want to buy a big toy, then this is where you go. I shouldn't say that, but if you want to, big, large pieces of equipment for whatever, right, in physics or biology or anything, right, this is the place to go, is the MRI program at NSF. Okay, and as it says, it supports instrument acquisition and instrument development. Generally, they want to spread them, or they want more than one user. These things should be kind of in use all the time, or as much of the time as they can be. They should help train students on them. They're pretty big. They're 4 million, up to 4 million, and there's limits on how many submissions per institution. Okay. So finally, before we get into the last of these cross-directorate programs is career. The NSF Career Program supports early career faculty who have the potential to serve as academic role models in research and education. These are prestigious 5-year awards. The proposals are selected based on a plan of outstanding research, excellent education, and the integration of research and education within the context of the mission of the organization. Okay. So the point is, these are not excellent research excellence prizes, right? They need to be differently comprehensive than a pure research proposal. The educational component is important, and the education component needs to be integrated with research. They're not intended as a default funding mechanism for new assistant professors. They really are special awards. Not every project is suitable for submitting to a career. So if you submit to the career program, you really should read the solicitation carefully and follow the instructions. And then there is also, this is one where there's limits on who can apply. You need to be a tenure track or equivalent faculty member. You can't have acquired tenure. You can only apply 3 times. And there are some other conditions too. This is kind of a good segue into the MPS broadening participation programs. So there's 3 MPS-wide broadening participation programs I'm going to highlight. And then each division has what I would call division-based opportunities that are really sort of specific and set up they're really pretty highly targeted. Okay. So of the MPS ones, the first and maybe the least complicated is the MPS Alliance for Graduate Education and the Professoriate. So that's AGEP. That's an acronym that's been around for a long time. And these are graduate research supplements. So these are designed to promote an increased representation in MPS research. They're only available as a supplement. So in order to apply for this, you need to have a grant, or you need to have a pending grant. Okay. And the they also can only go to AGEP or AGEP legacy institutions, which is a large enough group of institutions that it's worth talking about in a general audience, because a lot of you will be working at AGEP institutions or AGEP legacy institutions. There's a URL that has the full list. Okay. And basically it's full ride for one student for 2 or 3 years, for up to 3 years, I think it is. Okay. And the emphasis on the graduate student eligibility, the emphasis is placed on broadening participation and diversity. Students should not be supported by the federal government, by some other federal program. They really should be only getting their money from the AGEP GRS supplement. And they need to be US citizens, US nationals, or US permanent residents. So that's not negotiable. And the average award is about $60K a year. Okay, so those are supplements. You have to have a grant. It's really not, well, you have to have a grant to apply for it. Next is LEAPS. And this is actually LEAPS MPS. So this is launching the early career academic pathways in the mathematical and physical sciences. These awards support the launch of the careers of pre-tenure faculty in MPS fields, particularly institutions that do not traditionally receive significant amounts of NSF MPS funding. And the goal of the LEAPS is it's to enable PIs to submit subsequent proposals to traditional already existing NSF funded opportunities. So these are starter grants for faculty members at particular institutions, which are delineated in the solicitation. And the awards are up to, you can get over 2 years, they're up to $125,000 a year. This is a sort of a trimmed down version of career. Yeah, and actually it says here, you have to be at a PUI predominantly undergraduate institution or an R2. Okay. All right, so that's LEAPS. Next is Ascend. So LEAPS is leaping up, Ascend is ascending to get actually a job. So these are for postdocs. Okay, so MPS Ascend, the goal of the program is to support postdoctoral fellows who prepare to become leaders in MPS fields. And it focuses again on participation in STEM of members of groups that are historically excluded or currently underrepresented in MPS fields. They're up to $100,000 a year for 3 years. Okay, so that's been going since 2021. A related program, which is, okay, it's on the slide so I can talk about it, but there's nothing to look up as far as I could find on the web quite yet, it's Mathematics and Physical Sciences Ascending Faculty Catalyst Awards. So this is starting in 2024, and the purpose of MPS AFCAs is to support successful Ascend fellows as they transition into a tenure track or equivalent faculty position. In order to apply for one of the Faculty Catalyst Awards, you have to have had a MPS Ascend. All right, and these are also $150 a year for 2 years. Okay, so those are 3 sort of MPS-wide initiatives. There are division-specific initiatives, which of course for interdisciplinary, they can involve interdisciplinary stuff, but they're kind of housed in the individual divisions and make more sense to division by division. Okay, so these are programs that provide opportunities with each division. They tend to focus on partnerships with centers and institutes that support individual research with the goal of increasing recruitment, retention, and degree attainment by members of those groups most underrepresented in MPS research. And there's 5 acronyms down in the bottom in a box: PREM, P-A-A-R-E, I don't know how you say that, PREP, PREC, and PRIMES, one for each division. So we'll go through those quickly, one slide at a time. All right, partnerships for research and education is PREM. So this is material science. So it enables, it's partnerships between minority serving institutions and materials research, science, and engineering centers. So these are not at the individual level, these are more at the programmatic level. Since 2004, this one's been going on a long time. There have been 46 awards, including plus 12 seed funding awards, up to 700,000 a year for 6 years. So these are significant size. They've trained 150 postdocs, graduated more than 1,800 students with PhDs, MS, with some kind of post-secondary degree. Okay, and many of those go on to careers in higher ed and STEM. Next is PAARE, Partnerships in Astronomy and Astrophysics, Research and Education. So PAARE enables, this is astronomy and also partly physics, but mostly astronomy. This is to get partnerships that provide pathways into astronomy research, foster diverse, inclusive and equitable environment. Partnerships improve astronomy research and create opportunities for students and faculty research, strengthen education infrastructure and research capacity. Okay. So this actually also another enrollment goes back to 2007. There's not, I mean, they don't make that many awards, 15 awards between 2008 and 2018. So they're about 1 million an award. Okay, it was paused in 2018 for a while, then restarted in 2022. When it was, so this was a reassessment, which happens periodically. And it was clear there is still a need. In 2022 and 2023, 22 additional awards have been made. And these are for 10 million total, so about $500,000 an award. Okay, and this program the expectation is it will continue. And you can see there's different partners, the ARP, Windows on the Universe, and their development awards for up to 2 years, and then fully developed up to 5 years. So next, physics and chemistry get their own slide together. So PrEP is Partnerships for Research and Education in Physics. Okay, so this is the partners are Physics Frontiers Centers. And the awards made, this is FY22, I think, 6 awards, $5 million, about $5 million. And there's a text box that explains more about PrEP in physics. The chemistry version is PrEC, Partnerships for Research and Education in Chemistry. So this is, the partners are 8 centers for chemical innovation, facilities, and institutes. So there are 8 different centers, and they've made 3 awards. And you can see what the little blurb about it. And overall, there have been over 12.5 million was invested in FY22. And these, they do, if these are tricky to find now because the solicitations are, the way the funding cycle works, we're after the end of a fiscal year. And so there are no new due dates for these. So I didn't put down the solicitation numbers because you need to look up PrEC and PrEP if you want to find more information, of which there's a lot, but it will be updated presumably sometime sooner rather than later. So next, this is the DMS one, Partnerships for Research Innovation in the Mathematical Sciences, PRIMES, it's a nice math word. So this is, the goal is to build partnerships between minority serving institutions and the DMS supported research institutes, of which I think there are 8. So it gives an opportunity for researchers working at minority serving institutions to participate in it funds participation in some kind of activity at one of the mathematics research institutes, most of which are semester long. Or I guess this says it could be a year long, although they tend to be semester long. And it's basically a travel grant. The awards are up to $400,000 for 2 years. Okay. And you can read more about it in the solicitation. Okay, and finally, the last on this broadening participation is, it's called, this is a very, very special. This is a DCL, it's for MPS High. So this is for high school student research assistantships. So the purpose is to broaden participation in mathematical and physical sciences among high school students with the goal of encouraging the high school students to continue to college and then continue to careers in STEM fields. Okay. And this is a supplement program. So if you want to apply to it, you can look up the number 22041. You have to have a specific student identified, and only one student, well, actually a maximum of 2 students, and you can get up to $6,000 supplement to an existing grant. per student for up to 2 students. And finally, here's an MPS, maybe starting in 2018, 2020, 2019, the relative last few years, there's new investigator workshops. And here's a picture of all the people at one of the 2019 new investigator workshop, which might have been the first one. So these are people that have been supported in one way or the other by some of these programs that I just talked about. All right, last but certainly not least, on the last couple slides is about undergraduate research programs. So probably the premier undergraduate research program at NSF, which has been going on since the 80s, are the REU sites. Okay, so REU sites, these are independent proposals to initiate and conduct undergraduate research projects that engage groups of students in research. Okay. So REU sites can be based on a single discipline, or they can be interdisciplinary. Actually, I feel like recently they tend to be more interdisciplinary than they were in the past. But there needs to be an intellectual coherent intellectual theme that the research is centered on. Proposals with an international dimension are welcome. Okay, that's the main REU sites. There's also REU supplements. So if you have an NSF grant, you can always apply for an REU supplement to support undergraduate research. Okay. So these are relatively small supplements. There's low overhead in applying for them, and they're pretty straightforward. Okay. And if you have questions about supplements in particular, you should always talk to your program director. And this goes for pretty much all supplements. If you're going to apply for any kind of supplement, you should talk to the managing program director about the possibilities. All right, and on the right here is a map of REU sites funded by materials research it doesn't actually give a date, it just says a few years ago. So, I mean, this would actually be interesting to see every division in MPS funds a lot of REUs, and of course they're cumulative. So if we had a map this size with the current REUs, it would be a lot more densely populated than is apparent, but they really do occur all across the country at all different types of institutions. All right, and the last funding opportunity, so the REUs are for students. That's for students, faculty, guide student research. Well, what about, I mean, there's also opportunities for researchers at primarily undergraduate institutions. So this is facilitating research at primarily undergraduate institutions. There's 2 types. There's RUI, which is research in undergraduate institutions, and the other is ROAs, which are research opportunity awards. Okay, so RUI proposals, these are for faculty research projects, which can include students, but it's not necessary. But there are constraints on the institutions that are eligible to apply. They have to be predominantly undergraduate institutions, and predominantly there's a specific definition of this. If you work at one, you might know it. If not, you can look it up. It has to do with the number of I think it's fewer than 20 PhDs in any discipline in the past 5 years, something like that. They really have to be true undergraduate institutions. It's kind of an overlay on a regular proposal for researchers that work at primarily undergraduate institutions. So there's no deadlines. The deadlines go with whatever the umbrella program is that you're applying to. And you can, when you start the application in research.gov, the first thing you choose is RUI with this solicitation. And then after that, you choose the thing that you're really applying to. And when you actually do it in practice, it makes more sense than when I explained it. Okay. So again, there's no single deadline, and the deadline depends on what the particular funding opportunity. And funding recommendations are made by whoever is making the decisions about that funding opportunity, whatever you apply to. The last slide, still have questions. Ask early, ask often. Here's for questions that don't get answered now, the sort of the natural point of contact for any directorate, for any division, is the deputy division director. they may or may not answer an email, but they may or may not answer an email directly, but they will respond to every email in one way or another, which could be forwarding it to somewhere else. So these are the division contacts across the MPS Directorate. That's it.
Thank you very much for that, Matt. And now we'll dive into some questions that we've received. Starting with, as an early career researcher, can you discuss the trade-off between spending time to build a track record for applying to improve funding chances versus applying as soon as possible?
Yeah, take us just a second. We got a million questions here right at the end, so it's going to take me. Maybe we could just go through all of them because I haven't really got a chance to look at them. But for this one, the trade-off between spending time to build a track record before, how much work do you do before you apply? It really depends on the discipline, I would say. That's one thing. Another thing to think about is that part of the there's a lot to be gained from applying for NSF grant in terms of getting the proposals are reviewed. Every proposal gets 3 reviews. Most of them get discussed in a panel, and there's a panel summary. So you get a lot of feedback, whether or not an award is recommended or an award is made. So it's not wasted time. I guess that's the way to look at it. You don't want to submit something that really has no chance, but submitting things that are works in progress, or submitting something and getting feedback and then building on it and then doing it again, that's really a best practice. That's the best way to learn. So that's what I would say about that one.
Okay. Could you provide information on funding mechanisms for workshops?
Yes and no. Okay, or maybe yes and yes. Certainly, so I'm a mathematician in Division of Mathematical Sciences. We have a specific program solicitation that's designed to support proposals for conferences and workshops, and we get quite a few of those, and we do support quite a few workshops and conferences. Outside of DMS, outside of math, I don't know specifically what happens in other divisions or in other directorates, but if you look in the PAPG, so then the proposal preparation guide, there is a separate category of submission types, which is conference proposals, and there are rules about those. If you want to apply for it, and those are across all NSF. If you want to apply for something as a conference grant or workshop grant through that mechanism, it's really a good idea to talk to the program director who would be involved and get their input as to what the practices are in their program or their division.
Right. And PAP guide, in case we want the full name, proposal and award policies and procedures guide. Okay, that's out of the policy office, so I had to fix that one, right?
Yes, thank you. Yeah, I know. I just remember the policies. Yeah.
I think they knew what you were talking about.
Yeah, well, they should change it back to GPG, right? I mean,
right. The old grant proposal guide. That's right.
Yeah.
Another question: are emerging HSIs or Hispanic serving institutions eligible for the partnership grants, or do they need to be designated as official minority serving institution?
Yeah. So okay, my understanding about these designations is you really need to be designated before you're eligible, but I would be hesitant to actually say that that's a policy because things at NSF never say never. Right. So if the right thing to do would be to ask a program director for the program of interest and see what their policies are, or look in the solicitation, because a lot of times it's written pretty clearly in the solicitation what the requirements for institutions are.
Right. The solicitation has a whole section on eligibility. So yes, that's the first place I also would recommend to look. Another question: does the lead PI for a prep award need to be housed outside of the Physics Frontiers Center that they want to work with, or can a center apply for the award to work with various people at minority serving institutions?
Ooh, that's a good question. And if I were a physicist, I would probably know the answer. But I mean, again, this is one I think it would be good to talk to somebody, the program relevant
a program director in a division in physics who actually works on this, and they would be able to tell you. My guess is that the money is really supposed to go to individuals and not to centers, but again, never say never. So.
Okay. How can we receive notification of MPS events such as the new investigator workshop?
Okay. New investigator workshop, I'm not completely sure, but if you go to if you root around on the NSF web pages, you can find a lot of links to get signed up to different what are they called? Listservs and mailing lists. I mean, there's a phenomenal number of them out there. I don't know if there's any like main source for all of them. Like
isn't it My NSF? You can select which where your interests are. So if you go to that My NSF site, you can say, I want to learn about any new policies coming out or any like I say, events in MPS. So you can target whatever it is where your interest lies. So you check the boxes for your interest, and that's where you'll receive information on it.
Wait, in My NSF? No.
Mm-hmm. Is it My NSF?
No.
Is that what it's called? Yeah.
No, My NSF is internal to NSF.
Are you sure?
We're
going to figure that out.
Research.gov?
No, not research.gov. No, not research.gov. Give us a second. I was pretty sure that was that's where the information is. So yes, My NSF is the portal that will take you to sign up for updates to access your subscriber preferences, enter your contact information, which will be your email address, and then you submit so you can find out. You would then set your preferences for whatever it is you would like to receive information from. Yes.
So I just Googled My NSF. Can we do this in real time? Because I think this is probably helpful. I mean, I Googled My NSF and can't find it.
I type My NSF and there it is right here on the screen. NSF, where discoveries begin, email updates. To sign up for updates or to access your subscriber preferences, please enter your contact information below. Email address, fill it in, submit or cancel. So.
Okay, my browser is not doing that, but okay. All right.
Yes, okay. Well, hopefully you all are trying it out there and you are successful. If not, then you can let us know in the Q&A if you were not or were successful using My NSF. Okay, where are we now? In my experience, some early career grants favor proposals that have an advisory board that provides robust guidance and evaluative oversight to the junior faculty. Will this type of project-specific academic oversight be important to a successful LEAPS MPS grant?
My experience with LEAPS, which is limited because it's only been around this is maybe the second year, is that the answer is no. This is just a regular, it's a regular competition, and what you see is what you get with the solicitation, right? So I think that I don't think that kind of academic oversight, it would be, certainly in DMS, for math, it would not be normal.
Well, let's see. Can you tell us a little more about the Centers of Chemical Innovation?
Sorry, no. Yeah.
Okay. And I see someone did say the URL for My NSF, and that's the same one that I went to. You'll see in the Q&A, there's a long service.gov/delivery.com. That is the My NSF, yes. So you would go to My NSF to get the information and fill in the blanks, the boxes that you want your information, wherever you want to subscribe to.
Okay, great.
Okay. Let's see. The LEAP solicitation says it focuses on institutions that do not traditionally receive significant amounts of NSF MPS funding, such as some minority serving institutions, predominantly undergraduate institutions, and Carnegie Research two universities. However, this is not reflected in the eligibility requirements. Should an R1 MSI institution apply?
That's one I would really, what's listed, what the slide had and what's in the solicitation, what they say the focus is, that really is the focus, right? But it's this, NSF never wants to be exclusionary. And I don't think it's really possible to, anyways, okay, so the question is worded, should an R1 MSI apply? And I think the question I can answer is, can a R1 MSI apply? And I think the answer to that would be yes. The should is a different thing. And again, this will depend probably on the discipline inside of MPS that is going to get the proposal. But
Okay.
there would be, again, there would need to be some focus. If the money is going to if going to an R1, there's going to have to be some justification for it, that it meets the requirements and the goals of the solicitation.
So I'll ask, can you speak to the importance of serving as a reviewer for NSF?
Yeah, I think this is how I got the job I've got right now. It's a great job, right? I mean, yeah, if you want to review for NSF, there's, I mean, I know where the link is on the DMS webpage. I'm not actually sure how to do it. Maybe this My NSF has a link if you want to sign up for a reviewer. The normal procedure is to sign up. One normal procedure to make sure you're on a list is to just sign up on one of the lists where it says that they're looking, do you want to be a reviewer? Click yes, and then provide your information.
And do you agree that NSF and the community can gain from their benefits on both sides from someone serving as a reviewer, like the individual that's serving as a reviewer, as well as the benefit it is to NSF, serves to NSF? Oh,
no, yeah, this is, okay. Yeah, I guess this is what I was trying to say, maybe not so well before. Yeah, I think that there's definitely benefits to serving as a reviewer. I mean, you get to see, you get a breadth of exposure that's really hard to get in a normal day-to-day academic life for most people, right? So, yeah, it's a learning experience. You can also, okay, proposals themselves are confidential. You can't talk about a proposal once you've walked out of the panel room, or the panel discussion is over, or you've submitted a review, whatever the process is that you're using, whatever the review process is at the time. But that doesn't mean you can't gain from seeing how other people structure things. The discussions, part of serving as a reviewer is is most of it, a lot of it is panel review. There are scientific, it's a lot of scientific discussions by, people that are sort of peers or near peers. And there's also the sort of the professional development opportunities that occur when you're serving on a panel. I think it was maybe possibly more when panels where everybody was in person, but it's still certainly the case in the hybrid environment.
Okay, and someone else is agreeing, saying serving as a reviewer helps when you're writing your proposal, your own proposal. You get to see the process. It's extremely helpful. So someone else volunteered that information to also share that it was helpful for them as well.
Right. Yes. And actually, yeah. And it's, every time I'm in a panel, I tell the panelists this, but then of course I forget when somebody asks. But yeah, understanding how the process works from the inside, you get to see what it looks like from the inside. That can make a huge difference in how you present things and, what you submit and when you prepare proposals.
Okay, well, I see no more questions coming in. Speaking slowly to give someone one more shot. But if there are no more questions coming in, then I will go ahead and thank you very much, Matt, and thank you to everyone for joining us today. I hope you all have a wonderful day. Thank you again for joining us.